All right, let's get started. Thank you for being here. Um, oh, and remember to go see Lindsay, the young lady here, to register to win a Raspberry Pi. So worst case, you wouldn't have lose your time. You good? All right, so welcome. Today we're going to talk about NoSQL object relational mapper or object NoSQL mapper and see whether or not that kind of combination makes sense, right? And I tried to be objective, but frankly, I wrote the presentation and I'm working on a project named Hibernate OGM, which is whose goal is to actually persist the data into MongoDB, EHCache, Infinispan, Neo4j, and more of the NoSQL solutions. So I'm somewhat biased, but the idea here is for you to get some kind of interaction and so that we can discuss these kind of things. So as I was saying, first of all, hopefully you will a little bit better understand, when you want to use NoSQL, when you want to not use NoSQL, and what it would imply in your actual IT infrastructure. But also, I'll try to show you how useful it could be to have an object something mapper instead of using directly the APIs that each of the solutions offer. And you might disagree with me, that's fine. I'm definitely giving my opinion here, and the idea is to make your brain start thinking about those kind of things. So I've got an official title, which is not that, but it's mostly useful inside the company. Just remember that I'm doing a lot of the data-related stuff for JBoss, the middleware side of Red Hat. So historically, I've been working a lot on Hibernate, but nowadays I'm also working on other projects like Infinispan, the data grid, TID, which is a data virtualization engine, and ModShape, which is a JCR hierarchical database. I'm quite heavily involved in the JCP and also in some research projects from the European Union. And if you're interested in the JBoss technology, especially the community side, I encourage you to go to asylum.jboss.org. It's a podcast that I do about every month or so, and we try to talk about one technology. For example, two episodes ago, we actually discussed security with the actual security team of JBoss. That was very interesting. Well, for me at least, so hopefully for you too. So let's get to the meat of it. I've got several myths that I will try to debunk or confirm, right? But we don't have a lot of time, so I'm going to have to cut some of them. So I choose two of them. The first one is, I've got this new project coming up, and let's say Oracle is not good enough for that project, so I need this NoSQL thingy scalable stuff. The question is, am I okay to actually go and use one NoSQL tool and be good for it, or would I require to have more than one? So let's dive into that. And let's discuss a use case. Let's say I'm a web shop, and I've got billions of products, and I'm lucky because I've got billions of customers, paying customers, and maybe not just not paying customers. And on top of selling stuff, I also need to analyze the link and patterns between product and people, who buys what, why, in which circumstances, and so on. And for some reason, my platform is very Web 2.0, so there is a lot of comments on each of the products. So I need to store that, and of course, people need to be able to find the product. So let's make it searchable. And if you think about it, any project in China is going to have to deal with billions of products, billions of people, and so on. So it's not that weird. So let's start simple. Let's start with a document store. So the stuff here is the ability to store everything related to a document, in this case a product. And I can put properties on it, I can put sub-properties and nested collection, those kind of things. It's pretty interesting because the schema is self-describing. I got the title and the actual value of the title, so I can get that information inside each document. It's pretty good for nested structure, and it's very easy to use and quite flexible for a lot of things. So here I'm describing one of the product of type phone, and I've got several options and so on. But then I told you I wanted to analyze some of the patterns. So the problem with document store is that you can do queries on stuff that are inside a document, but when you want to link documents with one another to do some kind of correlation and analysis, well, this is not really the good tool to do that. So in my hypothetic example, I will start using a graph database, let's say Neo4j, to express not every property that you see here, because they wouldn't fit in memory or in the graph database that is only one server focused instead of being scalable across multiple servers. But I will express the link between them. This product has been bought by this user during that time for that reason and so on. And what I will be able to do on top of this graph database is do pattern matching queries. Can I find the people that in these circumstances bought that kind of product and see how many people got there, and then maybe extract some recommendations for future usage. There's also the common stuff, right? Let's say I'm super popular, so I really have gazillions and gazillions of comments, and a document store is not really super well done to store series of very vast amount of data. What is very good is Cassandra or similar products. Why? They're very good in time series, so because you can add more column in a linear fashion, and they're able to store many and many and many columns per what they call per key, and retrieve that super fast, because physically in the file system, the information is actually stored that way. So it's just a seek and then an actual sequential read to extract the information and push it back to you. I've got other use case where maybe I want to add some kind of cache to remember the recommendation that I've computed with my graph database. Maybe I want to pre-store that kind of information in a key value so that when a user comes in, I got a key, a super fast lookup to access a recommendation and actually propose that to the user. And of course, I might want a full text search engine to actually, so that people can actually find my stuff. So I started with one NoSQL engine, and I ended up with 4, 5, and even more. What's happening is that each NoSQL product is very good at one specific use case or one typology of use case. And what you have to do is really embrace that and use that NoSQL engine for that use case. Meaning, when I've got different use cases, I can try and twist the initial product that I've used, or I could embrace the NoSQL values approach and just add a different product. And the problem you will get with that is you will start duplicating the data, because when you think about it, it's product and users and comments, and those are actually spread across the various products in a duplicated fashion. So how do you keep the consistency between one and another? And for each of the NoSQL engine, I will trade maybe speed for some of the flexibility or the ease of use, say a transaction, for example, and so on and so on. So if you start down the NoSQL path, you will realize that you will need more than one NoSQL engine and choose one over the other. And that will lead to data duplication. So maybe a tool will be able to help you here to keep the data consistent, even if the data is duplicated into these different systems. To hear about the next following myth, you will have to come to my session tomorrow at 12:30 somewhere in Moscone. No, not Moscone, somewhere here. Yeah, it's 12:30, 1:30 as far as I remember. So is JPA only for relational database? Well, you will have to wait tomorrow. Does it make sense to store entities into those NoSQL store that are not relational and everything? Again, the answer is going to be tomorrow, but you can expect that the answer is going to be yes, more or less. Another one is, what about the real power of each NoSQL engine? Do I actually need to use the underlying API versus having this kind of abstraction? Is it fine to have the abstraction? So we will discuss that. Let's do a little break. I don't know if you've seen this one. It's basically when you write a comment in a code that is that is for you in the future when you have to read back the code and realize things. It's a bit what happened in Hibernate OGM. We wrote some stuff and realized things were not perfect, and we had to rewrite them again and again and again and improve stuff over time. So I know I had that experience. I'm sure you had, one script somewhere doing parsing that at some point you had to reopen and then what the hell, have I written that day? The next myth is about the query language. Is it fine to actually use JPQL versus the actual native query language of the NoSQL solution? Again, the answer is going to be answered tomorrow. But let's focus on this one, which is, okay, ORM can add, or object NoSQL mapper can add some kind of value, but is it enough? Is it enough to pay the price of the abstraction and benefit that, or is it just an overhead that is not really needed? So let's dive a little bit into that. As I was saying, Hibernate ORM is, well, an ORM, generally speaking, is some kind of abstraction on top of the underlying engine. So it could be a document store, it could be a graph database, it could be something like Cassandra, it could be, what's the other one? Well, a key value store and so on. What is good about the abstraction is, A, we can do a lot of stuff better in an automated way. Sure, you can do some kind of batching on your own, but we can actually automate that kind of batching for you, something you wouldn't have done because it's a bit too costly and a bit annoying to have to batch the list of operations and apply them, for example. And we have more knowledge, more information about an object and the related objects and the relation between them, the cardinality, those kind of information. And we'll see that a little bit later, but we get some interesting information out of it. And JPQL is different than how you interact with a database in the sense that in a database, you express the kind of change you want to apply. So you say, in a relational database, you say, update this table where the value is that and update those fields, right? It's really action-oriented. Whereas an ORM says, here is an object graph. I've done some change on it, and I know those objects are actually managed. Please do a snapshot and look at the difference and apply the changes for you. So it's kind of a slightly different paradigm. It's fine to use one or the other. I personally like, that, and that's why I'm working on ORMs. But, it's I guess some people, dislike that. I'm personally pretty happy with it. So let's zoom a little bit. An interesting thing about the object mapper, Hibernate OGM in this case, is that we looked at each of the solution, document store, graph database, and we tried to find the most natural mapping for each of the stores. So we wouldn't store stuff in an artificial or synthetic way into a graph database. We really tried to embrace the fact that it's about nodes that have properties and links are very important because that's how you do queries and so on. So we looked at each of the solution and we thought how to basically provide the best mapping for each of the underlying things. You could do the same. It would require you to work and learn the tool and probably do some mistakes and try again and so on. And the second interesting thing is that it's somewhat declarative. You express the fact that you want to store that information in that way, maybe with annotations or a programmatic mapping API of some kind. So there is less bug on your side, at least more bug on the ORM side if there is to be a bug. And it's good not only for how you store the information, but also how do I do optimistic locking in this specific document store versus another. And we can think of additional things like that. So we do a lot of things transparently for you thanks to the object relational mapper for NoSQL. The other interesting thing is, and that's really the key for me, is the fact that in some ways, the object and the object graph is the canonical version of your data. And we can split it apart and duplicate the information from that and store the information in a duplicated way, let's say in the document store. Maybe we'll store just the order and maybe the order with the list of objects, or maybe the user with its list of orders. We will duplicate the information here so that when we have to do a query retrieving the order and the list of items inside the order, we can do that in one quick query instead of having to look for 3, 4, 5 different documents and do some kind of aggregation. So think of them, if you're familiar with relational database, think of them as a materialized view that is, yes, duplicating the information, but the object OGM actually makes sure that when you store the data and change the data, we will update the duplicated data everywhere in a consistent fashion. So again, the bugs, if there are bugs, are actually on our side, and you just express declaratively how you want the data to be persisted so that it addresses your queries in an efficient way. And if you push that a little bit further, you could think, well, yes, okay, I can store the data in different ways in one of the NoSQL store, but what about storing the data in different ways across different data stores? And remember, if you have several use cases and a more complex use case, you will have to use more than one NoSQL engine to best address each of the use case. So here you've got the object representation on your left side, and that's a canonical representation. And we see changes, and then we apply them on several of the underlying stores. For example, if you want the detail of a news, that would be stored in a document store. And if I want the latest news in a time series fashion, in the latest, let's say the last 10 news in my home page, I can use something like Cassandra to be, which is efficient in storing time series type of information. And the consistency, again, is handled by Hibernate OGM that would do the hard work for you. Another very interesting thing is because we look at this object graph and we do a snapshot and see what has changed, we actually internally generate a list of events that have happened. This entity has been updated with that property and that property. The link between that entity and that entity has been changed, or a link between that entity and that entity has been added. Thanks to that information, we can actually, do the action-based operation on the database, but we can also piggyback on those events and do additional stuff. So we've done that for a couple of our projects. One is Hibernate Validator, which will validate your entity, verify that it's, let's say, the email is actually an email and not just a string, a random string, and stuff like that. Every time you change the entity, we can apply the validation at the right time, right before pushing the data to the database. Hibernate Search actually maintains a full text index consistent with your database. So when you do a change with your database, we also do the change to the index. And you just have to express that through a couple of annotations in your entities. And you do a query that is somewhat object-oriented, where you express, I want all the objects whose title look like this one, and maybe where the location is within 5 miles of this radius, and so on and so on. And finally, we can do data historization, meaning that instead of changing the data, yes, we change the data in the database, but we also store the fact that we change the data from that value to that value, so that you can do queries back in time and realize what was the state of your data. So these are examples of stuff working for Hibernate ORM, but also Hibernate OGM. Nverse does not work yet for OGM, but that's coming. And you can see how you could listen to events and do some kind of interesting operation on your IT system. A quick one, are ORMs slower than actually using the native API? Maybe, but there is a lot of things we can do for you. We have a natural session level cache where instead of reading the same object several times in a consistent way, in a repeatable read way, we can actually read the object from the local cache instead of having to read the object from the data store again. As I was saying, we can do a lot of automatic batch updates transparently for you without you having to manually code this kind of queuing of operation and then apply them and so on. And what's interesting is when we started Hibernate OGM, we worked with the Infinispan team because we wanted to store JPA object inside Infinispan. And we've been fighting each other to try and see who was the most time-consuming in the stack using a profiler. And we've been fighting each other on improving the code and so on and so on. And pretty much ORM as it stands is fairly negligible, maybe 5% of the time it takes to store the data in the underlying data grid. And the data grid is known to be extremely fast, so we're pretty confident ORM is actually pretty good with a fairly minimal overhead. So it's worth giving a try. So as you can guess, I definitely disagree with its myth. I definitely think object relational mapper or object NoSQL mapper actually bring value to the table, and that you could, get some of that. So I went a bit fast, but I hope you agreed with me, or you were sensitized to the fact that, yes, it could actually make sense to use an object mapper for those NoSQL solution. And maybe, by having this abstraction, I can gain additional features and benefits, and including around denormalization and the fact that you can express materialized view to have, very fast query down the roads while keeping the consistency. So I did talk pretty much in abstractness. How did we do it in Hibernate OGM? So first of all, we are very close to having the first final version of the project. We hopefully in a month and a half, we should have GA. The kind of backend we support MongoDB, InfiniSpan, EHCache, and Neo4j. So a graph database, 2 key value store, one which is more data grid, and MongoDB, which is the document store. Those one we're very confident. We worked hard to find the best mapping possible. So we're confident we will support them in the future without changing the way we map stuff. We can actually, you can express a query in JPQL, and we will convert them into their respective native query language for MongoDB, Neo4j, InfiniSpan, and EHCache. And by the way, if you need to express, let's say Neo4j is more powerful to express pattern matching, you can write a native Neo4j query and map it to an entity and retrieve that entity in a managed way and then navigate that graph and so on and so on. So you don't have to use JPQL. You can use a native and more powerful query language of the underlying NoSQL store. You lose the flexibility and the portability, but that's usually okay in this case. We support the ability to refine how you store the information. For example, what is my read-write concern for MongoDB? What is my read plus write level for Cassandra as far as consistency is concerned? You can express that via annotation or in a programmatic fashion. And we can map just about any entity and association you can think of when you come from the JPA world. In the future, what we want to do is support multiple backends. So today we support the storage into one backend or another one. We want to support this multiple backend at the same time. That's going to be very next in our work. Likewise, multiple denormalization. Today we do one kind of denormalization, which is the out-of-the-box version, and we will plan for a way for you to express additional denormalization. And we want to support additional ones, additional backends. CouchDB, which is almost there, but we're not super happy yet, so it's still in beta. And Cassandra, which is very interesting for its time series and very challenging to see how you can best map that into an object world. So somebody has been starting on that, so we're getting feedback already, but there's still a bunch of work to do on that area. That's pretty much it on my side. Please go and try Hibernate OGM, so hibernate.org/OGM for Object Grid Mapper. Grid is kind of the historical thing. We support more than just data grids. Please, if you have feedback, if you think it's the worst project ever, if you think it's the best project ever, just give us some feedback. We're interested. We have a pretty decent doc, but if you want to improve it, just go ahead. Come and talk to us, even if it's to say, I'm not interested in that. It's always interesting feedback for us. So again, don't forget to go at the booth to register for the Raspberry Pi draft to gain it. And if you have any question, just tell me and I'll try to answer them. Any question, guys? All right. Well, thank you very much for attending, and see you around. Thank you. So the roaring is about to happen. Yes. And the Emmanuel